Okay, thanks for coming. And I'm going to be talking about continuous delivery with Docker containers, basically. And so I want to start by highlighting Kao, who is the product manager for Docker, and they gave some presentations at DockerCon last year. And so I thought that this would be a suitable person to pick out. Here I have a slide in the same style as Matthias yesterday. It's not a very interesting slide, so I thought I would put a map of where I work, because there's kind of Japan all here, and Okinawa is way down, like quite a long way away from the rest of Japan, and closer to places like Taiwan. And more interestingly, I'm going to give a brief introduction to Docker. And so, first of all, I want to talk about images and containers. So images are kind of like, almost like a snapshot of a VM. It's a collection of things that you've put together in some kind of prototype for what you want to use in the future. And a container is an instance built from that image that you can use to like run commands in. As to why use Docker, because it's basically ubiquitous and because Windows has the best support with Docker containers at the moment. I think Microsoft are maybe working on other types of container technology that you could use, but I'm not really sure. And so this is kind of the most common technology for containers, especially on Windows. Why should you care about putting LabVIEW in Docker containers? Well, because I don't really like waiting for my builds to happen. And if I have to wait for my builds to happen 6 times in series, that takes 6 times longer. And it would really be nice to be able to do those in parallel. But anyone who's tried running multiple copies of LabVIEW of the same version on the same computer will know it's not that much of a fun experience. And so containers can help you solve this problem. They're comparatively lightweight when you reference like VMs as an alternative. I would say that James had a slide showing the RAM usage of his VMs. That, in my experience, has still been the limiting factor for me running multiple containers. And so I'll talk a bit more about that later. You're never going to have cache problems if you build from basically a new computer every time. And with the exception of you don't have a working Docker engine, you're not going to have it builds on my machine but not somewhere else kind of problems. And the scalable comment here is with relation to cloud hosting of containers. So all of the testing I've done so far has been on like my actual desktop, but in principle you could run these containers in Azure or AWS or something like that. I would say if you're going to do that, check the licensing, because as I'm going to mention a little bit later, there are some details. And yeah, did I want to just highlight again, the parallel builds is really useful for containers here. I gave a presentation a couple of years ago at the GLA Summit and talked about some of this, but I just want to like re-highlight that you can use Docker containers to build things with LabVIEW. And this can be packed project libraries, which is mostly what I build, but you can also do things like applications or FPGA bit files if you want. You can include things like DACMX and CRIO drivers, and you can build for CRIO targets. I don't think that you can run code that uses DACMX inside a container at the moment. And I don't know if things like gRPC will help us, abstract some parts of that away. Because you can run containers that hold Linux as their container OS inside a Windows host, if you wanted to build in LabVIEW for Linux, you could also do that from a Windows build server, but I haven't done that. And on this slide, I'd also like to thank Chris Stryker for his blog article a couple of years ago called Container Excitement. Almost none of that is in this presentation, but it was very encouraging to be told that you can do this. And so thank you to him for that blog post.
That doesn't apply to macOS.
You can't build macOS containers on a Windows host. No, I think you need an actual Mac for Mac builds. I think that this is generally true for most languages and most systems with Mac, and that's unfortunate, but yeah. So if you have questions or you want to interrupt, please just shout out. That'd be great. And also, The licensing that I have in the Docker files I'm going to share, they are using a serial number to license LabVIEW. If you have a volume license management agreement, then Felipe has a blog post, which is in the comments of this presentation, but I will put a link on the end that talks about doing that in his previous company. So that might work out for you. So how can you do this? I want to say this is quite easy. If you have a working Docker engine on your Windows host, and I've mostly looked at Hyper-V for the isolation mode here. You can use process isolation, which is kind of like a technical detail, and then there's some more discussion of this in the README for this repository. But you'll probably find it easier if you can use Hyper-V. You can go download the scripts here, and then run one command line, and it'll take some length of time that depends on your computer. For me, it's maybe 40, 45 minutes to build 3 different images. And those images are for like 2019 LabVIEW, 32-bit, 64-bit, and Compact Rio on 32-bit. I would say that the advantage of having multiple images is that you don't run into the problem that James talked about, where if you have 64-bit and 32-bit on the same image, you might occasionally have them not behave so well. Also, your image would be much larger, which you don't really want. And then after you've done that, set up your build steps. So I'm going to show some examples with GCLI and the Application Builder API. I think that those are both fantastic tools. I would say that the documentation for the Application Builder API sometimes leaves something to be desired. If you are struggling to work out what on earth some of the functions do, I would recommend probably having an actual build specification open for the same types that you're trying to build, and then kind of cross-reference the names and try and find the appropriate VI to handle your problem. And so, yes, here is a screenshot of some parts of one of the VIs that's involved in my PPL build action. And you can see these parts of the Application Builder API and how I've wrapped together some parts of the GCLI code inside a class to let me write to the command line and give output and things like that. This repository is also public now. I don't think it's very likely that you would use this code directly, because probably you have your own steps that you want to follow for building things. But you can use it as a reference of like how I've done things. And I would also say that, yeah, one of these VIs sets conditional disable structure properties from a config file in your repository. So if you, like James, would like to set those at build time, there's an example here for doing that. Okay, and at this point, I just want to say I did write this slide before yesterday. And so, despite the fact that it really looks plagiarized, it wasn't. And so, yeah, this is like a good place to ask if anyone has questions so far, maybe.
How do you go to point number 4?
Yeah, okay, so we can continue with that. There are some comments on point number 3. Anything?
Do you need a Windows license for every, so like a VM, you have to technically have a Windows license for each VM you run up. Do you have to have the same for the Docker containers?
So running on a Windows host, a Windows desktop host, you do not need a license for containers, but you do need to be using it for development or testing. If you want to use it in production, you're supposed to use a Windows Server host, and then the licensing for Windows servers is slightly different, and depending on where you put those, that will be separately handled. In principle, you don't need licenses per container, but the server licensing bases itself on the number of CPUs, I think. If you're looking to do it like in large-scale production, go and check those details, because like it will be important to you. If you're going to do this on a computer that's under your desk and you're using Windows like Pro, Windows 10 or something, then you will be probably covered by the developer terms, I would guess. And again, as John had, I'm not a lawyer, and that's based on me reading the documentation. So.
There's also license for Docker itself, for commercial use.
Yeah, so that's also true. Docker Desktop, which I've used for this presentation, but you don't have to use, has commercial license terms. If you are what they consider to be a large company, which is to say you make more than a certain amount of money or you have more than 250 employees. If you're smaller than that, you can use the Docker personal license, I think. But when you exceed that size, then to use the Docker desktop, which is not the same as the Docker engine, you need to have the commercial license for Docker. For Docker engine without the Docker desktop, it is possible on Windows, but it's quite a bit more complicated, and I'm not going to discuss it in this presentation. If you want to talk about that, we can talk about that, but I don't have a huge amount of knowledge on it.
Sorry, last question. You said you can't really run the DMX, etc., but can you run basic LabVIEW functionality if you're not bothered about hardware interfaces in a Docker container?
I don't know where the limit lies, but this code runs inside my container, for example. So the build code is written in LabVIEW, and it runs in LabVIEW during like the container. So some code will run. I anticipate that things that require, I'm going to touch on which bits probably more later, won't work. So going to step 3, I'm going to talk about a particular delivery system, continuous delivery system called GoCD. This was produced by ThoughtWorks mostly, which is the company that Dave Farley, someone mentioned earlier, was working at the time. Although I think it was his co-author, Jez Humble, who was the product manager for GoCD at the time. So in purpose, this is basically like Jenkins. I decided that I'd had enough of Jenkins after dealing with updating it and managing the 10,000 plugins. So here you have comparatively few plugins that are included or required. It does make it a little bit ironic that some of the rest of my slides are about plugins that I've written. So I'm sorry for that. And most of the server is written in Java. It's open sourced, and there's some UI in TypeScript and JavaScript. You don't need to care about like any of that. You can just use the web interface. It also has a RESTful API that you can call into to trigger builds if you wanted, or pass parameters and environment variables and things like that. So I think those are relatively like standard features with most like CI or CD systems. This is an example of the value stream map that they tout as one of their kind of like main advantages. The Wikipedia page tells me that value stream mapping is also known as material and information flow mapping, and is a lean management method for analyzing the current state and blah, 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 blah. And basically says these things take these as inputs and they produce these things as outputs, and they're connected together in this way. And so this is a screenshot of one of the PPLs that I build, and some of the things that it depends on, and some of the things that depend on it. And you can see that some of them have Git repositories, and in some cases, one Git repository has maybe 2 pipelines. In other cases, like lots of things depend on one pipeline, and so you can like see these kind of things and look at which time they built, when they were built, how long they took, look at the console logs, things like that. And so amongst the advantages and benefits of GoCD that I've found, I quite like this value stream map. It looks kind of nice, and so that's cool, I guess. I know that Jenkins has, I think it's called Blue Ocean, which is a new kind of API for doing some of these types of visualizations. I could never quite manage to work out how to get it to work with scripted pipelines, maybe because I didn't try hard enough, but there we go. And the documentation for Jenkins also became a bit confusing with the 2 types of pipelines and vastly different steps allowed in each. So I like that this is a bit simpler, there's a bit less stuff involved. And pipelines can be configured using JSON or YAML. And so all of the pipelines that I'm showing here are configured with YAML. And I have a repository, not on this slide or the next one, but probably in a future slide, where I share the scripts that I use to generate that YAML. You definitely probably won't use that as it is, but you can take a look at how I use some Python code to generate the YAML for the pipelines and the kind of steps and formatting that you can use. And that's quite useful for me. If you had to configure these all like one by one through the UI, it would take forever, and they'd all be the same, so you'd just be wasting a lot of time. You can also display custom tabs, and you can add manual approval if this is something you want. I'd say this is probably the opposite of continuous integration, but I did speak to some people who told me that this was a good thing for their workflows. So if you build stuff and you test it, and then before you deploy it, for example, you want to have someone click something, or you want to go between environments, or you want to have different setups and like manual intervention, it's possible to do that. And so I'm just going to show a custom display tab now. This is on the right-hand side, kind of a screenshot of part of one run of a particular test setup. And it's run VI Analyzer, and it's using Matt Pollock's VIA check style VI package. And I'm working on a plugin to basically generate this report and produce an HTML file, and then you can look at it like this, and you can click on the files, and they'll expand out to tell you which errors happened or what the problem was, and also the relative change. So there's like some -1, -2 in those boxes saying that this time it ran, it had fewer errors than last time it ran. And this isn't currently published. I'll probably publish it over the next week or two. But if you'd like to give feedback, there's a forum link here, and I'd like to thank Leah Edwards and Sam Taggart for the feedback they've already given me on this. And I have tried to integrate the changes that they suggested. So if you have things that you'd like to see in this, if you think you'd like to use it, then please go there and let me know what you want, and I'll try and include it. And so, yeah, the custom tabs can generate and show HTML files. You can show text. The one to the left of this, labeled VIA results at the top, is just the XML file that's used to generate this HTML. And that's the direct output of the VI package code. And for manual approval, you get this kind of GUI arrangement. So the first task passes, and then you're left with a, do you want to click here to go to the next one? I think if I, do this, no, pardon me, this, then I can show, so here you have the first task that looks kind of okay, and then you can click here, and then you get this kind of menu, you click here, and it starts the second task, and then it passes, and then you're happy. It's basically how that goes. And I guess if it doesn't pass, you're not happy, but then at least you can go and fix it. In terms of setting up one of these servers, there are downloadable binaries. You just go and download it and install it. I installed it directly on my host. They also have Docker images if you want to run it. You could run this in a Linux Docker container, so you probably wouldn't need quite so much space or concerns about licensing. And so this is just the kind of scheduler, basically. You can also install agents on the same computer, so that's what I've done for the VI Analyzer tests that I showed just above. And although you can configure simple pipelines on the GUI, and these three are, I would really strongly recommend that you not rely on that for larger scale things. The configuration repository option, where you write some kind of YAML or JSON file, and then you put it in a repository, and then the server will notice changes to that file and update your pipelines, is much more reliable in terms of knowing what you're doing and what happened and where things went. So yeah, this is the part of the Python code that generates my YAML file. It's about 600 lines in total, which is kind of verbose, but most of that is string constants that are templated into the YAML. It's available at this link, that's public. They've got permissive licenses, so do what you like. I think that there's a reasonable chance this could be useful to at least someone here, maybe, in terms of generating in pipelines, but you'd have to go and change exactly how you wanted things to work, or the commands you wanted to run, or things like that. And it specifies the number of pipelines you're going to have, and the stages, and the jobs, and the tasks. Stages being kind of the,
Is there any fundamental difference between YAML and JSON configuration?
I think that the answer is in principle no, but the YAML plugin is newer, and the author is the same for both of them, and he wrote the YAML one because he was unhappy with the JSON one, so I assume there are some things you can't do with JSON. If you prefer JSON, I guess you could go ahead and improve the plugin, but it's all open source, but if you don't care, then...
And then maybe use LabVIEW to generate JSON.
Yeah, so you can definitely use LabVIEW instead of Python if you want. I chose Python because I thought it was a language that everyone else seemed to like. I really don't like Python at all, but but I heard other people do, so for reusable projects, I thought this was a good choice. If you think that LabVIEW would be more useful, I can rewrite the thing in LabVIEW, but then you have to run it in a runtime thing. It's a bit more work to get it to run. And so I kind of hinted at this before, but despite deciding to use something other than Jenkins because I wanted fewer plugins, I then went and wrote 2. And you have to also separately download this Elastic Agent plugin, which is published on the GoCD website. If you want to use something like Kubernetes or like Docker Swarm, there are separate plugins for those. I haven't tried either of them. So my guess is that they're actually more a focus of GoCD's development. They're quite keen to have people build lots of big things in cloud arrangements. So probably they have better development schedules than the Docker plugin that I'm using, but this one is quite simple and straightforward, and it works well for me. And one of these repositories that I have has some instructions about how you install that and how you can get that set up. Basically, it's copy-paste the Java file into your server and then restart the server. And then the 2 plugins that I've written are for NIPkgs publication and fetching and installing. So at the end of a build, I want to create an NIPkg, and I want to push that somewhere. And then when I'm running another build that depends on that thing, I want to install the published artifacts from previous builds. And so I created something that allowed me to do that as a kind of build step. And yeah, the work in progress is the check style visualization. So there's the forum link. And in the future, you'll be able to go to this URL. But right now, if you go there, you'll just get permission denied. So this is a screenshot that doesn't really tell you anything useful. I just like it. And so this is the console log from part of one of my builds. And you can see the little arrows. You can expand them out and get what happened in each step. And it's showing the NIPkg installing like 4 or 5 packages here. And then a GCLI command at the bottom that's calling, with a library name and some dependency list, and then building a PPL. Some of these things are kind of hangovers from the previous build system, so I don't think there's actually any reason that I desperately need to pass the dependency list now. I could probably just scan that from LabVIEW, but I'm still doing it here. Yeah, so I just like screenshots of everything being green, and I decided I was going to put this in. In terms of potential issues, I would say that parallel containers use quite a lot of RAM. So in my case, I'd say they use like 1.5 to 2 gigabytes each. So if I run 12 of them, that's mostly okay. And then if I run 12 of them whilst I'm doing too many other things on my computer at the same time, then suddenly my computer runs out of RAM, and then Docker starts doing horrible things. So don't have too many containers running in parallel such that your system runs out of memory. Because then, like, I'm not exactly sure what the defined behavior is, but it doesn't seem to be very nice. The allocation time for a new agent is about 30 seconds on my computer. That, I think, will probably vary from computer to computer. You might get better behavior if you use a cloud provider, I don't know. And that's the time between me asking for something to happen and it starting to run a job in GoCD. If I actually run the containers through PowerShell myself, then I can get one started in like 4 or 5 seconds, which is much better, which means there's probably room for some kind of optimization here. I don't know where exactly that is. I might look into it, because it's a little bit annoying, but not a big deal. Another downside is that GoCD really seems to enjoy polling things. You can set it up to use with webhooks and like post requests from your source control system. But I haven't done that just yet. I think in the future I will go back to using the web service that I had for my previous build system, which basically received the post requests from GitHub and then worked out what it wanted to do about those and sent requests to my build system to build something. I'll do that in the future, I think, with this. And I think that's quite nice. And also your IT departments might like you if you can say that this is the one place that all of GitHub's things are going to go to, so you don't need to open up every port everywhere. Pipeline parameters. So this is the YAML that I'm using to define these pipelines in Visual Studio Code. And so for people who aren't familiar, the kind of boxed section on the right is like an overview. It's like the navigator panel in LabVIEW. And this isn't even the entirety of this file. So this is a very repetitive file. like, definitely would advise having something to generate it. And the problem is that some of these behaviors can't be mapped to parameters, which you can like use as a templating tool. Basically, artifact names and things, they have to be referenced, I guess, like at a concrete level when the file's passed, and they can't be calculated. So that means that you can't like have a template that has all of the things as parameters. And you'll see more if you look at this repository, like which things can't be included. But it does mean that there's a really big YAML config file. This is like 300 kilobytes for 50 pipelines, which seems a little bit excessive. And I would say it definitely requires that you script that file. Some miscellaneous discoveries I made whilst doing this. NIPkg feed add package is not thread safe. If you call this in parallel from 12 containers at more or less the same time, you are going to screw up your NIPkg feed. So I created a mutex that allows them to request a lock and then provide the key back from the lock. And I have a screenshot of that if anyone cares, but basically you need some way to prevent a bunch of different clients calling that command at the same time. Shallow clones, that's Git clones, don't include tags, and they don't include history. Now, given that's exactly the purpose of a shallow clone, you'd think that would be obvious, but it wasn't immediately obvious to me as to why my version numbers were all coming out at 0.0.0.1. I would say just use full clones instead of shallow clones. The gain from shallow in my cases hasn't been very important. If you have a really enormous repository and you don't want to clone all of it, there are some ways to like specifically fetch a certain depth or a certain number of tags. But yeah, like, don't believe that just because you can get something for nothing, it's not going to have an impact somewhere else. I spoke to someone about this yesterday. Downloads in PowerShell are really slow if you're displaying the progress. So if you use invoke web request, which is also aliased as curl or wget in PowerShell, then you can download things really easily, and it has a nice little progress bar at the top, which kind of comes in a kind of light green color and shows you how you're doing as it goes along. But the amount of time it seems to take rendering this is really slow. And so, like, even small downloads take a long time with that. And if you're doing it in a container and you don't want the progress bar anyway, you should definitely turn it off. So this is the like environment variable you should set, and then it will be like 50 times faster. Which, if you're downloading like NIPkg ISOs or something, it is noticeable. GCLI doesn't accept forward slashes, if this is a forward slash, in paths on Windows for the VI path. You can use it in the arguments, but not in the path to the VI. I guess this is because of the interaction with PowerShell. Just use the like platform appropriate separators and you won't have this problem. And I don't know how many people know this. I didn't until I was writing this presentation. But sometimes people complain that you can't find out what's in NIPkg feeds or where things are. But you can, in fact, fetch the packages file and then just read it. And so if you take the feed name and then add /packages.gz on the end, you get the packages.gz file. And then you can extract it and read the contents, and it tells you all of the packages that are listed on that NIPkg feed, which might be useful for some like niche case. In terms of future improvements, my top item was VIP installations because I don't have VIPM Pro, and this is quite convenient. I think I'm going to cross that off now, probably, because it sounds like we're going to all be able to use the command line soon, which is fantastic. And if you really need it earlier than that, the example Docker files I have show using extract archive and running the MSIs inside the GCLI installer. And so in that case, that's still a kind of fully automated process where I download a VI package from James's like repositories and then expand it and install it manually. You can do that. It's a little bit harder when you have the pre-build steps or the pre-install steps, but it's not impossible. I'd like to include some of these other things. And I think probably, especially if I go back to using a web service to trigger things, I might use the same web service or a different web service to handle the NIPkg publication. Because the mutex is fine, but it seems like a little bit of an add-on thing that I don't really think I need to have. And yeah, it would be nice to be able to use this in the cloud, maybe, and then I wouldn't have to keep worrying about the memory on my computer. That's basically that. So I'd also like to thank Jetco on the forums. If you're here, then thank you, and if you're not, I don't know who you are, but it was really helpful, the licensing command that you gave me. And if you want to see more about that, then the continuous integration forum on the NI forums is a pretty useful place. Obviously, James McNally for GCLI, and Casey May also for some testing of my Docker files, because he pointed out a few problems with the README that were not so obvious. And the link here at the bottom is a collection of the other links that are in my presentation. And there was something, can someone remind me what link I didn't have? Oh, maybe no. I'll remember what link I said I didn't have in this presentation, and I'll add it there. So thank you. Are there any questions?
Thank you, Christian. So you're using an NIPm. There are a lot of package management technologies out there, even open source. I would not have made that choice, but just wondering if you're happy with that horse. Are you still happy having chosen an NIPm? Do you consider other things? Did you consider other things before using an NIPm? What's your experience?
So yeah, it's a good question. And since I was building something like kind of separate from LabVIEW, I could have chosen to use something that wasn't part of the LabVIEW ecosystem. Except I wanted to share it with people in the LabVIEW ecosystem, and I thought it was more likely that if I picked package managers that other people had used, that might be useful. I also had to do some work with NI packages anyway. Because there were some questions earlier about running code. There are some NI packages that will not install in Docker containers. And here is a list of the ones that I created fake NI packages for. And apart from the DACMX runtime core, it seems like you don't actually need anything that's in any of these packages if you're only building things. I suspect that some of them are very important to making things actually run. And so the basic process is create a fake package that doesn't do anything and says it provides the same things, and then add them to a feed that your computer can find and make the version number higher so that they get installed. And that works pretty fine. I would say that if NI fixed a peculiar issue in their dependency resolution with NI packages, then they could do this themselves really easily, and it would be nice. But yeah, I don't know what's going to happen there.
And your main use case is installing PPLs, right?
Yeah, basically, mostly PPLs. You can build applications, so my GLA presentation showed generating a runtime, like real-time application, and then running it on physical hardware.
I find an NIPm, lacks of features when you need to do some more stuff, like setting some ambient variables, do some tweak in the Windows registry. I mean, do other stuff than just put a file in a directory. Yeah, so you can use, like, the PPLs that I'm publishing are through file packages. You could use installer packages. Is that the name of the other thing? There are there are three types now of NI package, and some of them can be used to configure like MSI files and things. So if you wrote scripts to do registry settings or something, you could do. I don't have anything to add yet. Like, I guess it's not a perfect workflow. If you need those things, you might be better with something else. But you can still use the Docker files. Yeah.
We'll make this the last one, and then we'll move on.
Oh? So how does the Docker work with actual hardware if you actually wanted to have, say, multiple LabVIEW versions on your same PC, but you don't want to have it installed on your actual PC? How would it interact with, for example, Visa drivers or anything that's through Visa?
I'm going to go back to my title slide. And at the bottom I have a caveat here. All usages for compile time only, singing and dancing not included. So I don't know is the short answer. If you want to try it and let me know, that'd be great. I don't think it's going to work very nicely. Eric might have a comment on that.
Docker and most virtualizing software, actually. Docker's not unique here. There's nothing really special about Docker. But they're not going to work with hardware with the exception of if you put it at the base layer. I understand Docker is like a layering technology, right? So there's a base layer. Anything that interacts with hardware, you have to put in the base layer. It's like read the Docker documentation. So drivers, which interact, like NI's drivers especially, are all at the OS level, right? So you have to have them installed in the base layer if you actually want the driver to perform its functionality, right? If you want it to actually work. What Christian had in there, he's faking what those packages are, because unless you're actually trying to talk to the hardware, like all the dependencies don't care whether the driver is actually there or not for the purposes of doing a build. So he's tricking the system into saying the dependencies are there because I put these fake packages in place. But if you actually want the real hardware to work, you have to install that kind of stuff at that base layer. And the same is true in Docker for a lot of things that require a GUI. Like, he's talking about scripting and automating stuff, which you often don't want a GUI for. But a lot of stuff in LabVIEW, if you actually want to show a GUI, all of that GUI stuff goes through the OS layer, and that also has to be in the base class. So if you're doing stuff that actually needs a user interface or needs to talk to hardware, those have to be in that base layer.
Yes, so related to that, and I know I'm out of time, but I'd also say all the things that James said about VM and automation and things, and unattended modes, none of this runs with a UI, and Microsoft, as I understand it, is making it actively difficult to get a UI in Windows Docker containers. For Linux, I think there's some work going on outside the LabVIEW community about, like, X forwarding and things like that. So some people have asked me about that. I think that there's a good chance you could make that work, but I don't know about Windows. I think it might be more difficult.